Hello, good morning. I'm going to start by showing you the LSTM model we did for the tweet generation project, neural networks project. So we divided it into 6 steps. First is the initializing of the variables and importing of the libraries, and then importing and grabbing of the data. The third step includes the cleaning of the data and removing stop words and links and whatnot. Then feature engineering in order to prepare the data to be processed by the model, and then we do the model building as well as the tweet prediction and text generator, and then we do the model evaluation. So 7 is model evaluation. Okay, so we start by initializing the variables. First to connect and then we connect to the drive. In order to mount the drive, and then we import the libraries. We mount the drive because our configuration or API config files are stored on the drive. We import the libraries, and then here we enter the Twitter user we want to grab the data for. So for example, we want to grab for Elon Musk, so then we enter the handler name, and then we run it. Here's the path for the data, and this is for the initialization and library importing. Then we start grabbing the data. Here is the authenticate API function. It communicates with the Twitter API, and then it authenticates the user, so that using the API credentials that have been given to us. We authenticate it here, and then here is a function to grab all the tweets. We give it the handler, and it goes over the user timeline, and then grabs all the new tweets until the length is not greater than 0. Then it will return them. And then here is a function to read we already grabbed the tweets for Elon Musk, and we saved it for this demo. So here's a function that grabs the tweets from the saved CSV file, and here is the format of the data. Here's the CSV file that has the data as well, and this is the format for it. And then after importing and grabbing of the data, we clean the data. We have a function called clean tweet. It takes the tweet and it makes it lowercase. It removes hyphens. It removes any mentions or any other at symbols. It removes the hashtags. It removes the links, and it removes brackets and all the symbols. And then it also removes the stop words. We iterate over the data frame, and we clean all the tweets. Here is it. We also replace the empty tweets with none, and then we drop the none, the not available columns. So this is for the data cleaning. And then for the feature engineering, we convert the tweet data frame into a string, and then here's a couple of functions that we use for tokenization, segmentation, text processing, and whatnot. And then here we initialize the vocabulary and translate and the translators from character to index and index to characters. We also initialize the important parameters such as the sequence length and this step size. We segment the data using this function, and then we do vectorization by initializing the 0 arrays for one hot encoding, and then we encode the data, as you can see here. So this is the feature engineering, And now for the model building. So model building, we have our model, which is and which is an LSTM model, which has an LSTM input layer, followed by a batch normalization, as well as a silo activation function, dense layer with a batch normalization and silo activation function. We're using the silo activation function because it helps lower the chances of having gradient boosting happening in this model. And as you can see, we use categorical cross entropy loss because we are using the one-hot encoding output. And here we fit the model. We're 450 epochs. Now that the model has been trained, we can go ahead and do prediction in order to predict or generate a new tweet. So how that works is, first we start by finding the seed word. It's generally a random word that's randomly chosen from the training dataset. And then we also find a random number of words. Here we try to limit it between the lengths of to be greater than 10 but less than 50 in order to not have a big text generated. So first we find the first seed word, and then we get the sentence that's built after. So our prompt was will. Our prediction here says that will probably altogether that blah blah blah. So this is for our first seed sentence. We can do it again to find a second seed sentence and as well as a second output, a second generated sentence. Then we can go ahead and evaluate the model. So our second seed word is going, and here's the sentence. We can go ahead now and print the blue scores for our generated tweets. And here is the average score, 26%. Not bad, not good, it's average. However, it does indicate there's underfitting.